So today I'll be demonstrating a product that we developed. It's called a virtual data, and Madonna is 100% behind it. And luckily, she doesn't want to blow it up. But actually, at the end of the video, you'll be meeting Madonna. So the business case for the product is that it automatically adapts to database changes without any programming. And as a result, any applications that are connecting to data via the virtual data layer will automatically get synced on those database changes. So what I'm talking about is that the task of programming, testing, redeployment, et cetera, et cetera, et cetera, those tasks are completely eliminated. Now, what that means in terms of dollars and cents, we can kind of get a rough estimate of by considering the true cost of software. And according to the experts, literally 40 to 90% of that cost goes to maintenance. Now, even if you take the low number and you're dealing with an enterprise that's pretty big and or is involved in master data management, that's going to be a pretty big number. Now, according to Madonna, and it's true, that feature enables something called enterprise agility, which means that you'll be able to get things done more quickly. And when you look at product delivery, the fact that you're able to get your products to market faster means that, according to the marketing stats, you're going to be making more money. Now, there are a number of ways that you can deal with that savings. On the one hand, you can bank it. On the other hand, you can redirect your efforts to more profitable endeavors, or you can do a combination of both. But in any event, and again, I have to thank Madonna for this. The ratio of, the ratio of revenue to cost of operations is going to get larger, and as a result, you're going to become more profitable by virtue of the virtual data layer. Now, that being said, let me actually begin the demo. Now, the use case for the demo has to do with a company that wants to go from a database that isn't normalized to one that is. And for those of you that don't know what that means, is that for transactional systems that are involved with updates, deletes, inserts, et cetera, et cetera, et cetera, normalized databases tend to take up a lot less disk space. So it's a more efficient way to go. Now, typically what happens in that scenario is when it's time to adapt to the new database, a notification goes out to various teams, and the teams begin programming the affected applications to target, of course, the new database. What we're going to be seeing in the demo is, instead of that notification going to a human being, it's going to go to the virtual data layer, and the virtual data layer will automatically adapt without any programming at all. Now, we'll know the difference in which database the virtual data layer is targeting by noting that in the one that's not normalized, or entity not normalized, in the customer table, we'll see that there'll be an AA next to this name. Now, in the normalized database, we'll see in the customer entity table that there'll be a ZZ next to that name. So that being said, let's begin by grabbing some data. Now, for the demo, we've created an application that's using the virtual data layer to connect to data. And let's just verify that we're targeting the schema that's not normalized. And we can see that there's an AA next to this name, and that means that we're targeting the schema that isn't normalized. So let's provide the notification as suggested to the virtual data layer, talking about the customer entity, and we can see that that notification is in the form of a mapping. So let me quickly fill in the info. So having filled in the info, we note that the data source is actually an instance of SQL Server But it could have been any technology. It could have been Oracle, it could have been DB2, it could have been Sybase. In fact, behind the scenes, we have a config file where the instance names map to the database technologies. Now, interestingly, we could have had part of the object mapping to SQL Server and the remainder of the object may be mapping to Oracle. But in this case, it's very simple. We're using an instance of SQL Server. Now, the database name, as suggested earlier, is entity normalized, and that's true for all of the properties of the object that we're mapping. There are two tables in the normalized database. One is called customer entity, and that's accepting the customer ID and customer name, and the remainder of the properties are actually mapping to the address table. And then here we have the actual column mappings within the various tables. So that being said, let us go to the next page of the wizard, the final page. And as you can see, it detected from the information entered that we're going to be needing a join and a connection string. So as before, let me fill in this information pretty quickly. So having entered the information, let's complete the wizard and verify that in fact now, without any programming, the virtual data layer has adapted and is now targeting the normalized database. And that's quickly verified by the fact that we see a ZZ now next to this name. So that being said, I'd like to introduce you to Madonna. And it turns out that Madonna is a virtual entity. And this is a face that we've elected for her, or at least to represent her. And she is the artificial intelligence behind the functionality of the virtual data layer. Now, if you'd like to meet Madonna, or you'd like us to craft a demo for your particular use case, it can be as complex as you like, please call me at my cell phone. That's the easiest way to reach me. My name's Stan Tonconaghy, and my cell phone number is 305-519-5177. I can be reached at work via 800-314-9503. Select option 1, then select option 3. And then finally, my email is tonconagh, my last name without the Y, at emberleyclark.com. Well, that completes the demo, and we certainly hope to hear from you in the near future.